This video is going to look at some of the manipulatives we use in school for our concrete methods. So the children, these are just examples of some of the equipment that your child will use every day in their maths lesson. So first of all, we have our 100 square and our number line. So the number line is our linear representation of our numbers, starting from 0 and then counting up. When we're counting, we like to start with 0 because that's of our importance. That's where all our counting sequences will begin from. And you can see that the children would be able to use this number line to complete counting activities and basic addition and subtraction. So they'd be able to find 6 on a number line and count forward or backwards. Our 100 square is used in a similar way, but you can see that the numbers are laid out. They can look at the relationship between numbers. So you can see that the teens numbers all feature in a row. You can go in down, you can see that the ones numbers, we always have our ones in this column. And for example, in this column, our sevens column, we've always got a ones. The children can see the relationship by going down the column, that we're adding 1 to the tens number. And obviously when we go from left to right, we're adding 1 each time. So the children can see the consecutive numbers going up and the relationship between those numbers. These are images that we use throughout the school as a way of the children representing their numbers and using these in their mental and written calculations. Moving on, we have Numicon. So Numicon is a fantastic resource. Your child may have spoken about this before. Each of the shapes have a different number representation. So I've laid this out for you to see. So we've got 1, 2, and then all the way up to 10. These are really child friendly. The children can use them, they can manipulate them, they can see this visual image of that 10 is a 2 by 5 representation, which then helps them later on when we come to talk about arrays in multiplication. From a young age, so from reception, the children are used to handling these. The children are used to knowing what the shapes look like, and there's lots of things that can be done with these. You'll notice straight away that the odd numbers have a chimney, for example, so the odd numbers don't have a partners, whereas the even numbers, like our 8, has a flat roof, so each of the numbers have pairs. So even from reception, we can start to talk about odd and even numbers. You can use this for adding and subtracting. So we would have 3 plus 1 makes us our 4 shape, which as you can see, the children could overlap on the top and they could see that that's 4. The shapes are weighted, so they can use them in a balance pan, in a scale, to show that direct comparison and really understand what the equal sign means, that it's about balancing both sides rather than equals being the answer. Moving down here, we have our tens frame. So these can be used with Numicon because they again build on our representation. It's about giving these children images that they will be able to then apply. So you can see that our tens frame has the same image, has the same shape as our Numicon. And here is our number 8 representation, sorry. So you've got your 5 and your 3. So you can see that if we add 2 more counters, 8 plus 2 equals 10. So this is about building on their early number bonds, seeing those relationships with numbers up to number 10. But they're brilliant because they link quite well to our Numicon. We also have number strings, number beads. So here is one that we use in year 1. So we have, you can see you've got 5 red, 5 white, 5 red, 5 white. So this is building up numbers to 20. So the teacher may use this to say, I've got 12. So we've got 5, 10, 11, 12. What have you got? They can use it to show number bonds to 20. You can obviously move this across and you can just work on numbers to 10. And these also in school, we have some that go all the way up to 100, which are really good for Key Stage 2 in particular, when we're dealing with numbers up to 100, and also when we're linking decimals and when we're thinking about place value. We have number fans, so we would use these in school to show me. So the teacher maybe have all the children on the carpet, show me a number which is even and is greater than 7. So they could show number 8, and you get an instant feedback because you can see all the children's responses at once. You may have heard your child talking about chips and peas. No, it's not from the fish and chip shop. This is what your child is talking about. So we have our peas. These are our ones deans. The actual mathematical name is deans, but we like to call them chips and peas. So we have our chips and we have our peas. And then when they get higher up the school, they start using hundreds which is our 10 by 10 grid, as you can see. And then they even have a 1,000 block where we have 10 hundred stacked on top of each other. So the children in year 2 and 1 are really familiar with partitioning numbers. Partitioning simply just means breaking down numbers. So in this number here, we have 4 tens, and we have 1, 2, 3, 4, 5, 6, 7, 8 ones. So we've got 4 tens, 8 ones, which would make 48. And the children from a really early age in year 1, they are building these numbers, thinking about the relationship, and then they can use these for adding and subtracting when they get in year 2. And when we move on to the pictorial, children, we draw these as our method, as our written method. So the children would actually physically draw lines and dots to represent these chips and peas. So if we were going to do 48 plus 2, the children could line this up. I'm going to struggle one-handed, but the children can line this up and see that that is 10 ones. You can't have 10 ones in that column, so they're going to exchange to become, we've got 10 ones now, and that moves over. So now we've got 5 tens and 0 ones, and in there we would use our placeholder. So we use chips and peas quite a lot in our Key Stage 1 maths and into year 3. We also have our place value tables, which build on chips and peas, but each of our discs represent a different digit. So you can see on here, so this is one that I would use in year 5. You can see in here that we've got 100,000, so there are blue counters. We've got 10,000s, 1,000, hundreds, tens and ones. And then we move on to decimals. So we've got 0.1, 0.01, so hundredths, and we've got thousandths, which actually is in our year 5 and 6 curriculum. So the children would be able to manipulate these counters. They would be able to understand that if I had 10 in one column, we would then need to exchange. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if I had one more, we would then need to exchange all of those. So 10,000s is going to equal 100,000. So we use these to see the relationship in our place value columns between the different digits. Obviously, the numbers, the discs are not representative of size, but they're really easy for children to be able to handle and for children to be able to explore the correlation. So this place value table would now give us 405,234.124. And in Key Stage 2, they learn that this 0.1, we have to just say the digits. So 0.124. Thank you for listening. If you would like to practice some of this and you don't have these skills, these manipulatives at home, then I had a thought about what you possibly could use at home. So you may have some equipment like this. So just an ordinary die. Okay, you have 2 dice, straight away you're having number sentences, straight away you're having problem solving. And playing board games which involve dice, so snakes and ladders, are really invaluable for your children's early counting and early number recognition. We have a chessboard. Straight away you've got an 8 by 8 number square, so we're talking about arrays. You could get a whiteboard pen and they could write on it, or you could take it outside in the garden and use it to play games. But here, a simple chessboard, there's lots of maths that you could do from this. We have dominoes, so early down we could look at doubles. So there we've got double 4 would give us 8. We can also think about fractions. So here we've got 2 sixths, which then can they find the partner? Can they find 1/3? An equivalent fraction. I'm not going to be able to now, put it on the spot. Here we've got 4 out of 4, 2 out of 2. They both equal a whole one. Can they find other ones? Or simply lower down the school, can we just match up numbers? We've got a 4 here and we've got a 4 here. So again, it's all just about building up their recognition of numbers. The new craze, this popping fidget toys, and they're actually brilliant, because if you look, ignoring our little shapes at the side, we've actually got a grid here. 1, 2, 3, 4, 5, 6, 7, 8, 9. A 9 by kind of 9 grid going on here that you would be able to use. Okay, if I have 8 popped out, here we go, we've got 8 popped out, and I take away 1, 2, 3, 4, 5, 6, 7, 8, yeah, and I take away 5, 1, 2, 3, 4, 5, what am I left with? There are some videos on YouTube which have brilliant uses for these, and they can be used all the way up to year 6. So for squared numbers and algebra, they're absolutely fantastic. So as a parent, they might be the bane of your life, but actually, if you are at home and want to do some more maths with your children, they would be really good to get you to be thinking about problem solving and about number patterns. And then we've got our Connect 4, where we can talk about patterns, probability, thinking about different ways in which the numbers can be represented. This is just a really quick snapshot of what we do in school, and I hope you found it useful. Lots of these resources are available to buy, but you don't need to. You just think of what you've got at home and what you can use to immerse your children in mathematics at home through playing games.